Hello friends, welcome to my channel Chemistry with DB. So in this video I'm going to explain to you electrophilic substitution, another type which is Friedel-Crafts reaction, alkylation or acylation of benzene. The three steps here again are the same as I have explained in my previous videos for halogenation, nitration of benzene, and otherwise also a basic video that I have created in which I have explained as to why benzene reacts by electrophilic substitution and not electrophilic addition, and the details of the electrophilic substitution. So the first step is creation of the electrophile. Then in the second step the electrophile attacks, and in the third step the catalyst or the halogen carrier is regenerated. Now what are Friedel-Crafts reactions? Friedel-Crafts reactions are when we add onto the benzene ring and increase the chain length of by increasing the carbon atoms. So the two types of Friedel-Crafts reactions are alkylation, when we want to substitute one of the hydrogen with an alkyl group, for example a methyl group or ethyl group, propyl group, any alkyl group, then in that case reaction type is alkylation. And if we want to add an acyl group, for example RC double bond O, then in that case, if we want to create this kind of a compound, then it's an acyl group that we want to add onto the benzene ring, then in that case the reaction type will be called acylation. Electrophile in either case will be either alkyl ion or an acyl ion. And in the third step, the halogen carrier, there is a halogen carrier is needed in this one. So if we want to have R plus, then we will have to have halogen carrier which is AlCl₃, or we could also use FeCl3. Now the reaction mechanism for, let's look into alkylation. So alkylation is, in that case, as I have told you, that we would use the halogen carrier which is AlCl₃, and the reagent that we are going to use would be the CH3. Let's say if you want to make methyl benzene, then it CH3Cl, so that is going to react with the AlCl₃, forming the CH3 plus ion. In the second step, the electrophile which is CH3 plus, it will attack the ring forming methyl benzene. In the third step, the catalyst will be regenerated. Now let's look into this in detail into the reaction mechanism. So let's say our target molecule is, let's say, ethyl benzene from benzene, okay, CH2 CH3. So since we want to put up ethyl group on benzene, so therefore the reagent that we would use would be chloroethane. Chloroethane, when it reacts with AlCl₃, then as in the case of chlorination, AlCl₃ will take the chlorine forming AlCl4 minus, and an ethyl ion will be generated. This is the electrophile. In the second step, what will happen is that the electrophile will attack the benzene ring. Okay. So the electrophile attacks the benzene ring, and the benzene ring uses one of the electrons, so in the process becomes electron deficient and forms a bond with the ethyl group. Now this is a intermediate species, it's a positive ion, not stable. So to make it stable, hydrogen leaves, giving the electrons to the ring so that the ring would reform, forming ethyl benzene, and the hydrogen that has gone from here, that is lost as H plus. In the third step, wherein the catalyst needs to be regenerated, so you see the intermediate that was formed here, AlCl4 minus, that reacts with the H plus that has been released from the second step by substitution of hydrogen from the benzene ring, and this forms HCl, and the halogen carrier is regenerated. So as a result of this, you have been able to make ethyl benzene, which was our target molecule, from benzene. If we wanted to make propyl benzene, then we should have started with 1-chloropropane. If we want to make methyl benzene, then we should start with CH3Cl. So I hope this alkylation is understood. Now let's move to the acylation. If an acyl group needs to substitute one of the hydrogen atoms, then in that case what we would, so acyl group, as you know, is this is acyl chloride. So we would need to use an acyl chloride depending on which acyl group needs to be attached to the benzene ring. Now we would again need a halogen carrier, which is AlCl₃, right, which will take up this chlorine from here, forming the acyl ion. Now in the second step, the acyl ion will attack the ring, right, in the usual way like all electrophiles do, and in the third step the catalyst will be regenerated. Now let's look into the reaction mechanism of this one. So let's say, for example, we want to make from benzene, so this is our target molecule, phenylethanone. So now as you can clearly see that this is an acyl group, right? So this is an acyl group. So now because we want CH3C double bond O to join the benzene ring, so therefore the reagent that we will use is going to be CH3C double bond O, and just put a Cl over there. Yeah, just use that acyl chloride along with the AlCl₃. This will form AlCl4 minus, and the acylium ion will be generated. Okay, so this is the positive ion that we have got. In the second step, what will happen? This acylium ion is going to attack the benzene ring. So C double bond O CH3, because this was positive ion, right? So therefore the attack will happen from the electrophile, and again in the same way like it has happened in all electrophilic substitution reactions, this becomes a positive ion because it has used electrons from the ring to form a bond with the CH3C double bond O group. So here is your C double bond O CH3, and this is the hydrogen that was already attached to the benzene ring. Now this is again an intermediate, and it's not stable because of being a positive ion. So the hydrogen gives the electrons to the ring so that the ring reforms along with the double bond O, the acylium group, acyl group. So we have got phenylethanone, which is our product, and this hydrogen, which is lost as H plus ion, this will have the catalyst regenerated. So in the third step, what will happen is the H plus will react with the AlCl4 minus, forming AlCl₃, the catalyst regenerated, and HCl. So in this way we have been able to get our target molecule, which is the phenylethanone, and the catalyst has also been regenerated. So this is how the acylation takes place. If it were for example CH3CH2C double bond OCl, then in that case propanoyl chloride will be used with AlCl₃. So depending on which acyl group needs to be added to the benzene ring, to be put on the benzene ring, accordingly you will decide on the which reagent are we going to use, right? Just put that with the Cl, and along with AlCl₃, the reaction mechanism is going to be exactly in the same manner. So I hope this electrophilic substitution of the Friedel crafts, alkylation and acylation, you were able to understand. And if you like this video, then please like, share and subscribe, and I look forward to see you on my next video. Bye bye, take care.